Hi, I'm Erica.
And I'm Ebony.
And we did our project on
The life cycle of a star. The life cycle of a star is an ongoing process of formation that starts with birth, expansion due to change and growth, and eventually death. Stars go through many different stages of life due to mass. So, we'll start with stellar nebula.
This is a stellar nebula, also known as a nebulae. It is a stellar medium made up of gas and dust that are found within the vast expanse of the universe. A star remains on the main sequence as long as it can fuse hydrogen and helium in its core. When a star can no longer fuse hydrogen and helium, the core shrinks up and heats up, forming an average star. Most of the matter that forms a star are elements in matter such as H2, CO, and other matter and elements. And essentially, these are the makeup for a birthplace of a star. So in one of the labs, we talked about star clusters and how they can tell us how a star becomes more larger and redder and more luminous. Its time on the main sequence is over. Moving on to red giants. As the core of a regular star contracts, hydrogen fuses with helium in the shell around its core. But when the rate of fusion increases and doesn't stop, the outside becomes hotter and redder, hence the name red giant. But before that, let's talk about the planetary nebula. Despite its name, it has nothing to do with planets. It is a region of cosmic gas and dust formed from the cast-off of outer layers of a dying star. Dying stars, like red giants, will continue to expel gas while the core continues to radiate energy. This energy expels gas, and the atoms and molecules in the gas become charged and emit light. This cast-off glowing is planetary nebula. But this process only lasts 20,000 years, which is a short-lived part of the stellar life cycle. Moving on to white dwarfs. As they cool off with time, they grow dimmer. But if they were to excrete enough matter and energy, it would explode.
If the matter in a stellar nebula would take a different route, the new phase would be a massive star. Massive stars are 10 times more the size of our sun. The weight of the outer layers is sufficient to force the carbon core to contract until it becomes hot enough to fuse carbon into oxygen, neon, and magnesium. When a massive star runs out of hydrogen at its core, it forms a red supergiant instead. Red supergiants can be red or blue, depending on its temperature. They use up hydrogen and helium in their cores within a few million years. They then burn the carbon. This continues with heavier and heavier elements until the star contains a core of iron. Fusion stops and the star collapses under its own gravity. Then this creates a supernova explosion. Supernovas take place during the final stages of some stars' lives. When they erupt, one supernova can briefly shine brighter than a whole galaxy. In the core collapse supernova type, the beginning of the supernova is marked by when the core of the star starts fusing silicon into iron. Moving on to neutron stars. Neutron stars are formed after the collapse of a core of a massive star. It's what's left of the star after a supernova explosion. The process of a neutron star turning into a black hole is known as gravitational collapse. It is a process that occurs over millions or billions of years. Lastly are black holes. This takes place when very massive stars come to the end of their lives. Once a black hole has formed, it grows by pulling in gas, dust, stars, and even other black holes around it. Over time, supermassive black holes can develop.
And that's all you need to know about
The life cycle of a star.